All right, chapter 6, exponents and radicals. Jack, what do you know about exponents or radicals? Do you know anything? Nothing about it? Sophia, anything? Hope? Nothing? Never heard of it before.
Well, yeah.
All right, Jordan? So what you're telling me is what we're learning is on the front cover? Yep. There we go. All right. So radicals and exponents, kind of think of it like this. It's not really like a new operation, but it kind of is like a new operation. So you know how we have like addition and subtraction and their opposites, right? And then we have multiplication and division and their opposites. So kind of think of like exponents and radicals are going to kind of be like opposites, all right? It's not a new operation because as Jordan said, an exponent is talking about multiplication, how many times we're going to multiply it itself. And a radical is just going to like kind of undo that. And it's going to tell me kind of like, oh, how many times can I divide a number by itself? And we'll kind of like get into that. All right. So if you look at the cover, there's a couple parts. Okay. And I try to put what we're doing on the cover so you can kind of look at it and see what's going on. So Harshan, we got a couple things going on here. We got B, B is the base, okay? That's the number that's going to be multiplied by itself. N is the number of times we're going to multiply it by itself, okay? And N is the small number, it's called the exponent. The whole thing together, B and N, is called a power, okay? All right. So here we go. What is a power? All right. So we refer to a power as an exponential expression. So kind of like the B and the E. Okay. They kind of switched it up here. So B is the base, E is the exponent, and the whole thing is the power. All right. And as Jordan was telling me, okay, and I think it's better if we do an example. 3 to the 4th is just talking about 3 times 3 times 3 times 3, which is 81. Does that make sense to you, Hope? It's not too hard, right? Okay. And if you just remember kind of like the basics, Matt, you'll be pretty good with this, okay? All right. And what are the basics? Really, all you need to remember is this. This little number is how many times we're going to multiply the big number by itself, okay? And you'll see me kind of go in and out of the forms to kind of help you guys out, okay? So Jordan said the base is the number that gets multiplied by itself. Looks like I forgot how to write. All right, and what is the exponent? The exponent is, oh, hey, Liam. How are you? Good, are you? Not bad. All right. So the exponent is the number that tells you how many times multiply the base, okay? So I'll let you guys write that. Liam, we got new notes. So let me give them to you. How was your break? Pretty good? Good. Did you go fishing? I envy you because I had to be in Baltimore on opening that. But I don't like going on opening that because it's kind of like shoulder to shoulder and it's just weird. Like they're weirder. So I might go to that. Might go to that. All right. Delaney, am I good? Are you're okay with that? Those are the basics. Okay. Now, what I like to do is I like to convert like between the two forms. Okay. So Andrew, here, this is what I do. Ready? My base is -2. How do I know that? That's the number that's being multiplied together. Do you see that? Now, I want just you. Do you have a graphing calculator? Can you get that out for me? Okay. All right. And this is important. And I'm just going to have Andrew do it for the sake of time. You ready? Okay. So the base is -2. Do you agree with me, Andrew? All right. And how many -2's do I have? Okay. Now, I want you to type that into your calculator. -2 to the 4th, just like you see it right here on the board. So -2 and then the caret button and then 4. And tell me, what did you get? So the -2, caret button, 4. What did you get? -16. Now, when you typed your this problem into your calculator, you got -16. But Andrew, ready? What's -2 times -2? Times -2. Times -2. -8 times -2 is, you sure? Negative times a negative is positive, right? So here's what I'm getting at. When we're typing this into our calculator, Andrew, we have to be very careful. So there is a difference between -2 with parentheses to the 4th power and -2 without parentheses. Do you see that, Andrew? So, Andrew, I want you to type this into your calculator now. We know -2 times -2 is 4, and -2 times -2 is 4, and 4 times 4 is 16. But when we typed it in without parentheses, we got -16. Did you get 16 now? Did you type it in with the parentheses? $16. So what I'm trying to tell you, Andrew, is this. If we're converting here, if it's a negative number, put in parentheses, okay? Does that make sense to you? Okay. Otherwise, what's going to happen is when you're taking the keystones or something like that, both 16 and -16 are going to be there. Because one, they're trying to distract you. Okay. So here, this is going to be -2 to the 4th power with parentheses. Got it? Here. Let's go with Kanye. What would this be? 4 to the what? 4 to the 3rd. Harshan, how many times am I multiplying 5 by itself? So I'm going to write this as 5 times 5 times 5 times 5 times 5. All right. Glad we haven't missed a step here with my smart board. That says 5 times 5 times 5 times 5. See that, Lynn? It's pretty good, right? Coming back from spring break, you need to learn to write again. All right. Right now, I got the training wheels on. Maybe Wednesday we'll take them off, see how it goes. Okay. All right. But Liam, until then, 3 to the 3rd. How many times am I going to write 3? 3 times. So this is going to be 3 times 3 times 3. See, look, already getting better. Any questions? All right, I'm going to try and break this down for you into like little kind of baby steps. Okay. Multiplying powers with the same base. Now, it says when multiplying powers with the same base, we blank the exponents. Now, I don't know what we do yet. Okay, Hope? I don't know what to do yet. I don't know what to put in that blank. But like I told you, if you know the basics, we can figure this out. You ready, Sophia? 7 to the 4th. How many sevens? 4. That means 7 times 7 times 7 times 7. Agreed? Times, right? How many sevens? You see that? Right? Now, I have a bunch of sevens, right? But I don't want to write it like that. It takes a long time. Agreed? How many sevens do I have? Now, there's got to be a way to go from here to here. Do you see it? What do I do? So 7 to the 4th times 7 to the 5th was 7 to the 9th, right? So how, instead of writing out this big long middle step, how can I go from up here? What do I do? What do I do with the exponents? Add them. So if I do 7 to the 4 plus 5, 4 plus 5 is 9. There we go. Do you guys see that? All right, let's look at this one. Ready, Destiny? How many A's do I have? And then how many A's do I have here? So if I have 6, 1, 2, 3, 4, 5, 6, and then 2. Not 6. All right. A times A times A times A is 4, 5, 6, and then 1, 2. How many A's do I have total, Destiny? 8. Does Sophia's theory of just adding the two exponents hold true? Yeah, because if I do a to the 6 plus 2, I get a to the 8. Now, let's go back. And look at that blank. AJ, what goes in that blank? What word? When multiplying powers with the same base, you add the exponents. Now, AJ, we started out this class with talking about opposites, right? Like addition, subtraction are opposites, correct? So multiplication and division were opposites, right? You okay with that? All right, now with multiplying two powers, right? When multiplying powers, we add the exponents, right? What do I do with dividing? Subtract the exponents. Now, how did you know to do that? I didn't teach you that. It's the opposite, right? So if I'm multiplying two powers, I add the exponents. Then if I divide, I must subtract. Now let's see that, right? Now, remember, I haven't done anything crazy yet. I haven't done crazy math. I've just stuck with the basics, right? I've just talked about what is the definition of, like, I don't know, an exponent. I just wrote it out. So let's look here at A. Let's look into seeing why we would subtract. Well, 12 to the 6th means I have 1, 2, 3, 4, 5, 6 12s on top, right? And 12 to the 2nd means I have 2 12s on bottom. With fractions, what do we do with things that are the same on top and bottom? Like, what's 12 over 12? 1, right? So they kind of cancel out, right? 12 over 12, they cancel out. How many 12s are left? 1, 2, 3, 4. All right, so EJ said I subtract to go from here to here. Is 4 equal to 6 minus 2? And the answer is yeah. So AJ, you were right. Make sense? But do you see how I don't have to like memorize that? Like little tidbit or fact, I can always kind of create it real quick. Like 12 to the 6th over 12 to the 2nd, kind of wrote it out, took me 30 seconds, and I was able to get the like, oh, I just subtract 6 minus 2. So drill. B to the 9th over B to the 3rd is B to the 6th. Because I'm just going to do 9 minus 3, and that's 6. Jackie, are you getting this? Copying it down? Okay. All right. So let's look at these. Does everybody see this page? This is everybody's next page. Okay. There's a couple of problems on here I didn't really go over, but I'm going to show you how to kind of work through these, okay? So if we're looking at this page, let's zoom in on question number 1. Jordan, with question number 1, there's like 2 things going on, right? We have numbers, which is 4, and then we have ends, agreed? Now, numbers, all right, if I have more than one number, I would just do that operation, right? If it was like multiplication, I would just multiply the numbers. If it was division, I would just divide the numbers, agreed? So since there's only one number, I just have 4, right? But now the question is, how many ends do I have? All right. So I know I have 2 here, but how many do I have here? I have 1. So that says n to the first times n to the second, which is n to the. So I have n to the first times n to the second. And what do I do? Do I add them or subtract them? Add them. So 1 plus 2 is 3. So it's 4 n to the third. Are you following me on that, Jordan? Okay. So the trick in this problem is when you don't have an exponent, it's understood to be 1. You have 1 of it. Okay. If you don't have any of it, it's going to say 0. Okay. And we'll talk about what that means. All right. Let's look at number 2, sticking with Jordan. Jordan, we have 2 parts again to this problem, right? We have numbers and we have variables, right? So the numbers, there's only one number, it's 4. How many n's are right here? Just 1. We're going to put a 1 there. And then I have n to the third right here. So what do I do with the 1 and the 3? I add them, and 1 plus 3 is? So we have 4n to the 4th. Are you okay with that? Pretty easy, right? All right. All right, let's look at number 3. Number 3, Kanye, we have 2 things, right? We have x's and numbers, agreed? So with the number, I don't really have much to do with it. I just have a 4. I have x to the 4th here and x to the 1 power here in the second part. To the first, which would give me, when I multiply these two, x to the What do I, well, I have 4 and 1, so I'm going to add them, and I get 5. Okay. Notice the title of the page was multiplication, right? So we're going to be adding the exponents here. Delaney. In number 4, we're going to talk about later what actually something to the 0th power is. But for now, we have 2 parts, right? We have numbers and we have variables. So here, 4 times 4 is what? 16. And now we have m to the 0 times m to the 0. What do I do with those exponents? Add them. So it's 0 plus 0. So we're going to write 16m to the 0. You okay with that? And like I said, we'll come back and we'll talk about what does it mean when something's like to the 0th power. All right, Hope, number 5. Do you see how I have 3 parts here? I have numbers, I have x's, and I have y's. Now the numbers are simple, right? I just have the 2. Agreed? So I'm going to start out by writing that. Now it goes to y. Now order doesn't really matter. I typically write alphabetically, but for the sake of the problem, we're gonna start out with the y's. Is that okay with you? All right. Now this is y to the what power? Just the y. So x is to the 2nd. But what is the y to?
To the first.
To the 1st. Would you agree? So we're going to put a 1 there. Now, if I have y to the 1st and a y to the 3rd, what do I do with the exponents? I add them, and it's to the 4th. Okay? So I have numbers, y's, and now I have to deal with the x's. I have x to the 2nd and x to the 4th. That's x to the 6th. Okay? Now, if you're kind of like me, kind of irks me a little bit to write it y's before x's. Like I said, I write it alphabetically. You can, okay, I don't know if Jordan's OCD or not, but this is also an acceptable answer. Okay, you can reverse that. Was that bothering you? You sure? Does it bother you when you miss work? I don't know. I was there. You weren't. Yeah, never stopped. At like 8:10, I would get up and I would have a conversation with myself. And it'd be like, Jordan, you at Linvilla? And then I would answer my own question, say, yeah, I'm there. I was like, well, I went there the other day to get a hot cocoa and you weren't there. So gotta have that conversation. All right, Matt. You ready for this one? Matt, with number 6, we have 3 parts again, right? We have numbers, we have U's, and we have V's. Agreed? With the numbers, 2 times 2 is 4. Now let's go to the U, right? We have U to the 0 and U to the 4th. What are we going to get? 4. U to the 4th, because we do 0 plus 4, and we get 4. Now the V. V to the what power? 1. Perfect. How many questions does this go up to?
16.
16. Where are we?
6.
Good. All right. 2 more. All right. Who do I want to pick on? Ooh, Harshan.
Our viewers will know.
Fine.
Never mind. It's not.
No. You said it.
Leave it up. You were from home, were you? Right.
Could've told you. All right, Emma,
Yeah.
let's look at number 7. In number 7, we have 3 parts. We have numbers, U's, and V's. Agreed?
Yeah.
Now, what's 4 times 2?
8.
8. U to the what power?
To the 4th.
To the 4th. Because we have 3 here in the front, and then we have 1 in the back. So 3 plus 1 is 4. And V to the what power, Emma?
4th.
4. Perfect. All right, Kevin. Kevin, you there?
Yeah.
All right, Kevin. In number 8, we have 3 parts. We have numbers, M's, and N's. Kevin, what's 3 times 3?
9.
Now let's go to the M's. We have M to the second and M to the second. That's M to the,
4th.
okay? And now we have N to the third and N to the third, which is N to the,
6th.
perfect. Despite what that says, which is 6. Even better. All right, now, what do I want you guys to do? We're not going to do an IXL. Okay, it's just back from spring break. You have 4 minutes, finish through 16. We're going to go over at the start of class tomorrow. So you got 4 minutes. All right, you got 8 problems. All right, the time per problem is about 30 seconds, probably a little less now. You answer one quickly, you can gain more time.